Okay, 2.1 linear systems. We are, okay, I'm pretty confident you guys have the graphing part of this down. Okay, so, just quickly. You can solve systems by graphing. We're leading into some pretty heavy real-world applications. We started linear programming last year. We're going to hit it pretty hard this year. Okay. I have eliminated most of Chapter 2 from this unit, and we're going to do linear systems today and tomorrow. Then we're going to do linear inequalities Thursday and Friday. Okay, so we are going to take our time and do this right.
Inequalities are cool.
I'm sorry that you don't like black people.
Oh.
Wait, I'm just kidding. I just said that, didn't I?
I just said that.
You belong in the NBA.
Why?
Well, a bunch of people are losing their jobs because they make one little remark, which I think is absolutely stupid. But okay, anyways, moving on. Dude, did you hear that he just got fired?
Yeah, he got his contract terminated. Now they own.
No, they just suspended him. Dude could have killed her, honestly. He's that strong. Like, knocked her out. Bam. Stone cold. Like, knowing how strong I was as a Division II college player and him as a professional athlete, dude could have killed her. So, okay, moving on. What is the solution to this system? Anybody? So I've graphed y equals x, and y equals negative x plus 1. This is y equals x. What's the y-intercept? 0, and the slope is? Okay, good. I'm glad we've got that after 3 years. And then, what's the intersection? Take a guess. An educated guess. John? The intersection. Don't make me go to my cup.
What was the intersection?
What's the solution to that system? Christian. Come on. What is the solution to that system of equation? There's a hint. 0, 0? Does that look like it sits on the... Just guess, you know? Okay, so... Okay, that's an estimate. Graphing is not a precise instrument for this. All right? So it is a method you can use, but be aware that it may not be perfect. These lines, if you're looking for some vocabulary, are consistent and independent. They're consistent because there's a solution, and independent because they're separate lines. Did I spell that right? Separate? Separate? No. But so, consistent, independent.
How do you spell separate?
It's ER?
What's the line for? Yeah. AR. AR. Definitely A. Definitely AR.
I thought it was AR.
It is AR. That's FRA.
I'm pretty sure it's A.
Yeah.
Moving on. Thank you. So we've had math, history, and now we're in English class.
It's A.
Yeah, somebody search it up. Right click. Go ahead. Okay, the two things I want to hit more rigorously are the algebraic methods. Okay, we're going to look at elimination.
Yes.
Yeah, bam. Nice job, Logan. Okay, I wasn't sure on that one. Am I celebrating? Okay, elimination. Let's solve this.
Oh, it's this stuff. I don't like elimination. I like the
Do you know? Okay, we can manage that.
maybe, I don't know, the one where you can just add and subtract.
That's this one.
Okay, I like this one.
We need to manipulate first, though. And I know you guys are pretty good at that, so. Yeah. We need to remember that we need to make one of the variables the same number or off by a negative. It doesn't matter. So if I multiply the top by and the bottom by, I get
Yeah.
quit being a jerk. It wasn't funny.
Sorry if I said anything in class.
You really mean.
That was funny. Add or subtract?
Add.
Why?
10 minus 10 is already 0.
Okay, good. You're going to add because those are different by a sign. Right there. Here's your sign. I did. You're correct. What do we got? 12.5x equals 50. What does x equal? Dude, quick, come on. That's an easy one.
12 times 4.
12 times 4 is
46.
48. So you add another 4 halves and you get 50.
4.
It is. Whole numbers are very nice.
That's substitution. That's not.
What's our y value now?
Yeah, so figure out what.
Okay, so plug it into one equation to solve for y. Take your pick. Oh, well, okay. Do them separate. I don't care. Fine. Be that way. Who's giving me the answer? Zach. I always get picked. Everybody else should be doing it too, by the way. Jared.
Stretching.
Uh-huh.
7.
Shh. Thank you, Zach. Thank you, Zachy.
I wasn't wrong answer.
Somebody's wrong.
Uh-oh.
Well, let's see what the
It's 7.
judge says.
7.
7? 1.5 times 4 is 6. Minus 6, 14 divided by 2 is 7. So our answer, write out the answer in the form of a coordinate. That's where those two lines intersect. Again, consistent, independent. Okay, consistent, independent. All right. Use substitution. It is easy. You can. I know. Pretty cool. You're going to do algebra.
Oh, algebra's lame.
This one becomes
Something.
just move the y over. Or the x. It doesn't matter, but it's less steps if you move the y.
I never.
Add y to both sides. Okay, where do I put this? That's the same as x, so where am I going to put it? For which one? Right there. All right. I'll change colors because that one is nasty. So we have 2 times y plus 2 plus 3y equals 8. Are we okay with what I just did?
Yeah.
Okay. Oh, he abandoned us. That popsicle stick. Logan. All for y. If you. Okay, so this is x. Goes that, right? I took that chunk and put it in for x. So y plus 2 goes in for x. Solve for y. What'd you get there, Miss Waterman? 5/4. Anybody else agree? Pretty sure I disagree with that. You guys want to see this, the algebra? Is that what your opponents tell you? Can you, and then okay, so there's, what's the x value, Kira? Nice work. The first time this year, isn't it?
I don't make all that shit.
Give me a second here.
No.
Okay.
You're a cheater. You can't do that.
I am a cheater.
Oh, okay.
You're right. The problem is we never defined any rules. What? It's a fraction. So if I make 8 into a fraction, that's 40 over 5. Subtract 12/5. Okay, so 3 times 4/5 is 12/5. Yeah?
I put it into a font.
3 times 4 is 12 over 5. 8, if I put it in fifths, is 40 divided by 5, yeah? Okay, now I subtract 12 over 5. 40 minus 12 is 28, because I'm a math genius. Now divide by 2. What do I get? 28 divided by 2 is 14. Okay, so our answer, Marissa, how do I write it?
Oh, you could have given me that one.
It is also consistent and independent.
I would have gladly done that one. Not for math, but.
All right, so that's your example. Let me show you what it looks like to have consistent and dependent.
Oh man, I was so close.
So close, you didn't even hit the bucket.
Yeah, she did.
It's like an air ball.
She hit the bucket. I'll try again.
Ooh. Okay, so if you have a consistent and dependent system, it's the same line. What does that mean? The graph might look like whoa. Okay, the graphs might look like that. And we have the same slope. Same y-intercept. Okay. How many solutions are there? Thank you. What might this look like algebraically? Okay, this is, so if I give you let's say y equals 2x plus 1, and it won't be this easy, but what if I subtracted those two? What do I get? You can say it, come on. What do you get on the left side? 0 and 0. Notice 0 is 0, it's true, right? Okay, so we get a true statement. Contrast that with parallel lines where you'll get like 0 equals 1. Okay, you'll get a false. So that's what the algebra and the graph would look like. Okay? Good? Let's go with inconsistent. What am I? Okay, these are parallel lines. Parallel lines have what kind of slope? Same. What about their y-intercepts? Different. All right. I'm sure off in the infinite those will intersect because they can't draw perfectly, but you get the idea. How many solutions? What?
0.
No solutions. algebraically. If I subtract those two, what do I get? Wrong. -5, thank you. Well, you're only a couple hours behind. It's a big hole to dig out of, but you can make it. Okay, so notice you get something funny like 0 equals -5. We know that's not true. No solutions. Okay. Do you want me to show you a word problem?
Yes.
Hard one.
But do you want this problem to have homework on the homework?
What?
Do you want this on the homework?
No, that's for you to do. Nice try, though. One. How's about 30? Okay, pick this one. 35, 37, or 38?
36.
I'd laugh if it was funny. Take your pick.
36. 35.
35, 37, or 38?
Oh, not 36.
That's why I laugh like that.
No, 35.
That's why I said you said no. Oh, no. I said no, not 36.
Okay, I'm not going to write down the wording.
Do 35. First Thursday was the third. Do we have to do that one? No.
Okay. As an incentive plan, a company stated that employees who worked for 4 years at the company would receive $516 and a laptop computer. Mr. Rodriguez worked for the company for 3.5 years. The company prorated the incentive plan, and he still received a laptop computer, but only $264. What was the value of the laptop computer? Or do you want to do a different one?
No, let's do that one.
Because that's a harder one than
Y
you have to do.
3.5x plus y plus 3.5x equals 516.
So we have one equation. The amount he gets equals the... Do we know how much the computer is worth? No, we don't. Okay. We might have to multiply that by 4. Four years. So this is going to prorate the computer. What we're going to do is prorate the computer money over 4 years worth of time. Okay. He only got $264, but he only spent 3.5 years, right? So solve that system. The hardest part of these word problems is usually writing the equations. Anybody want to take a stab at elimination or substitution?
Elimination. Substitution. No, elimination.
Okay, right as it's written, if you wanted to take this right here and put it right there, you could substitute very quickly. And this is what you get. Okay. This is the fastest method in this one. You can still eliminate, but you have to do some math to get there. Okay. So subtract here.
At least common after the.
What? Good. Something's not right here.
Ooh, something not right. Divide by 0.5.
Yeah, but we have to divide by -0.5, which gives us a negative value for the computer.
Yep, yep.
Bleh. Any ideas? No.
Looks like an elf.
Thank you.
Not you.
Oh. I've always wanted to be Legolas, especially when it comes to hunting.
Do minus 3.5.
It doesn't change it.
Yeah, it does.
No.
Yeah, if you subtract 3.5 minus 4,
You're still going to get a negative on the x equals.
no, 4 minus 3.5.
And here, do you have any ideas?
Oh, I know.
Well, you're not thinking very hard.
Do 4 minus 3.5.
This is not spoon feed. I spoon feed my 5.5-month-old son. You guys are a little older than that.
What if you factor 5 with 6?
Oh, you're still going to get a negative.
Yeah.
Still get a negative.
Let's do elimination. Let's do
It's not. No, it's not. That's not it.
It's
It's,
equation.
these are what's the issue.
Or be the y instead of the x. Or you get y between the left one.
Oh, yeah.
Go on.
Oh, good. I get to go ahead back.
Yep. I'm just gonna have to let that one sit.
So let's not do
You don't have to do it. We don't have to do the homework.
Wrong.
Still leave you 30.
If 32 and 33 are doable.
Go. Oh, yeah.
Whoop. Okay, look at 35. So we're practicing writing equations here. Shh. Zach, will you read us number 35?
Number 35?
Yep.
The first Earth day was observed on April 22nd, 1950. East of the week of April 22nd of energy, trying to show the support for environmental science. BAM's Cafe is offering a reduced refill rate for soft drinks during Earth Week for anyone purchasing a BAM mug. The mug costs $2.95, filled with 16 ounces of soft. The refill price is 50 cents. 16-ounce drink in a disposable cup costs $85.
Continue.
Are there any problems with
Yes, why is it called a soft drink?
I don't know, honestly.
Soft drink.
Because liquor is a hard drink, I would bet, but that's just a guess. So how do we code that in? So that's the first one. So the starting cost, if you buy one drink, it gives you $2.95, right? But if you buy another drink, it's just a refill. So 2 minus 1 is 1 times 50 cents. So you get 50 cents. Your starting cost is $2.95 plus 50 cents each drink thereafter, right? The other one, how much is it? What's your start cost? What's your cost per drink, though? Yeah, so it's just a simple 0.85x. Okay. So it's just 85 cents per. Part A asks, what's the break-even point, I believe?
Yeah, let's see if I can
So I'm pretty sure that the answer is 7. When you buy 7 drinks of either one, 7 drinks is when the top equation becomes more valuable. If you buy 8 drinks, the top one's the best way to do it. But if you buy 6 or fewer, the bottom one's the best way to do it. Okay. So practice writing those equations. I want to get you working. And I'm going to try to figure that other one out because that makes me angry that I can't.
Darby, you're finding homework Thursday night?
I haven't decided. I think I'm going to make that due Tuesday, so don't worry about it. Okay, this is not due until Thursday.
Homework?
This one?
And then,
But I'm going to caution you. Wednesday night is Powder Puff. I suggest you do this tonight. But there's volleyball. Okay, so there's volleyball and soccer tonight. Powder Puff tomorrow night. Just, I'm giving you 2 days at somehow for you to get this done. Okay? And this, whoever gets to play us is, because we lost last year
Done.
Did you really?
Sunday.
for the seniors,
Happy
and
birthday.
we're going to throw down the thunder.
Oh, okay.
Okay.
And then
All right.
everybody-
Everybody showed up.
No, you're in.